Hey everyone, welcome to our YouTube video, and in this video we are going to learn about a very important concept of chemistry, that is hydrogen bonding in the organic compounds. Now this is going to be a video of about 5 to 10 minutes in which I'll explain you about everything related to hydrogen bonding. So first of all, let me start with an example. In many of the places you might have noticed that a molecular formula of HF is represented in this kind of a manner, where hydrogen and fluorine are first of all directly connected with a direct bond, and then there are some few dotted lines in between. So what happens is that this kind of a bond, which in this diagram is shown by the bold black line, this is called a covalent bond, while these dashed line here, they are referred to as a hydrogen bond. Now technically, what is a hydrogen bond all about? So basically what happened is, in the year 1920, two guys, that is Latimer and Rodebush. So these two guys basically introduced the idea of the hydrogen bond to explain the nature of association in the liquid state of the substances like water, hydrogen fluoride, ammonia, formic acids, etc. So basically what happens that in a hydrogen compound, when a hydrogen atom lies between two atoms having high electronegativities, it shows a unique property of forming a bond as a bridge between them. Now this chemical combination between highly electronegative atoms of small atomic radius like fluorine, in this case oxygen, and nitrogen through hydrogen is referred to as a hydrogen bond. So for example, if you take the example of hydrogen fluorides, let's say. Now basically hydrogen fluoride has a great tendency to polymerize at a temperature let us say below 90 degrees Celsius. Hence it occurs as an H2F2 molecule. Now in HF, what happens is the hydrogen is attached to a strong electronegative element, which is fluorine. It is attached to a strongly electronegative element, fluorine. As a result, the fluorine acquires a partial negative charge. So for example, if I draw the structure of hydrogen fluoride here, this would be a delta negative charge here and a delta positive charge here because of the difference of electronegativity. So the hydrogen bond is basically defined as an electrostatic attractive force between the covalent bonded hydrogen, let us say in this case atom of one molecule, and an electronegative atom of the other molecule. Let me give you some more examples. So even if we take the example of water, let us say HOH would be connected in this manner, but the electronegative element would then be hydrogen bonded to the other molecule of water. So for example, this is the hydrogen bonding in water. Let us take the example of ammonia. So ammonia, as you know, has the molecular formula NH3. So we have N surrounded by 3 hydrogen atoms on its side, but then what happens is when it combines with another ammonia molecule, the nitrogen of the central atom forms a hydrogen bond with the other ammonia molecule in this case, and this one also has a lone pair of electron. Similarly goes for an alcohol. So the general structure of an alcohol is ROH, oxygen here being electronegative in nature. So what happens is we have an alkyl group, then an oxygen, and then an hydrogen. So what happens is that this particular hydrogen forms a hydrogen bonding with the oxygen of the other molecule. So this is another example of the hydrogen bonding. Now there are basically two types of hydrogen bonding. The first one is called intermolecular. The first one is called intermolecular hydrogen bonding, and the second one is called intramolecular hydrogen bonding. So there's basically a difference in the kind of way the atoms attached to each other. So in intermolecular hydrogen bonding, what happens is that this type of bonding is between two or more of the same molecules, different molecules when combined together to form a dimer or a polymer respectively, that leads to a phenomena called association. So these examples basically are the examples of intermolecular hydrogen bonding. Another examples can be of water molecule, formic acid, chlorophenol, nitrophenol, etc. Now in the second case, which is the intramolecular hydrogen bonding, now this type of bonding occurs within two atoms of the same molecule and leads to a phenomena called chelation. So this is the phenomena that intramolecular hydrogen bonding basically have to deal with. So this type of hydrogen bonding frequently occurs in organic compounds and results in the cyclization, let us say 6 or a 5-membered ring of the molecule. And a very good example can be orthofluorophenol. So for example, if you have a benzene ring right here, you have the double bonds here, then you have an oxygen here, and then what happens is that this hydrogen is attached to a fluorine. So this basically makes a partial bond like this. So this is orthofluorophenol. Now this type of hydrogen bonding decreases the boiling point of the compound and also its solubility in the water. The chelation between the orthosubstituted groups restricts the possibility of intermolecular hydrogen bonding and thus prevents association of the molecules, which would have raised the melting point or the boiling point. Now in meta and para isomers, chelation does not take place because the two groups atoms are far away from each other. Hence, in such cases, intermolecular hydrogen bonding occurs. Thus, we can explain the no melting and the boiling point of the ortho and the meta isomers. Now, the last topic that we will be covering in this particular video is the nature and the importance of the hydrogen bonding. So what happens is that hydrogen bond is merely an electrostatic force rather than a chemical bond. So hydrogen bond never involves more than two atoms. Bond energy of hydrogen atom is in the range of, let us say, 3 to 10 kilocalorie per mole, or maybe 10 to 40 kilocalorie per mole, about 1/10 of the energy of a covalent bond. So with the increase of electronegativity of the atom to which the hydrogen is covalently linked, the strength of the hydrogen bond kind of increases, and it definitely has very other effects on the physical and the chemical properties as well. So I hope that this short video about the hydrogen bonding in organic compounds was interesting enough. So if you are interested in more such videos, don't forget to mention your name in the comment box mentioned below. We'll be meeting soon in one of the next videos. The target is to upload close to 8 lakh videos on YouTube in the coming years. Now let's see how much of the target are we able to finish. Okay, so if you have any specific doubt in this, pretty much I've explained everything related to it. Like for example, we have covered covalent bond, hydrogen bond, and all these interconnected concepts in kind of a single video. Still, if there are any doubts that remains, please feel free to kind of mention that doubt in the comment box. Now, one more last thing I forgot is the stereoisomerism. So for example, in intramolecular hydrogen bonding, they have a strong influence on the spatial configuration of a molecule, and that kind of inhibits the isomerization of one form to another. So for example, the trans isomer of the indigo is so stabilized by the hydrogen bonding that it resists any kind of photochemical isomerization to the cis transformer. And there are also some effects of hydrogen bonding on the chemical properties. Now, the presence of hydrogen bonding basically also affects the chemical property of certain compounds. For example, dibenzoyl methane does not give up the normal reactions of carbonyl group, that is, it does not add HCN or NaH, SO3, etc. This is due to the formation of the hydrogen bonding. Another thing is that in polyhydric alcohols, they also have a high boiling points in their ether in spite of increase in the molecular masses of the ethers. So for example, glycerol having 3 OH groups per molecule can form more hydrogen bonds per molecule than that of water. So glycerol is more viscous than alcohol because of more binding sites available for the hydrogen bonding. Let me quickly check if anything else is left. Okay, maybe the next topic then we are going to cover is this wonderful topic called resonance. Now, resonance is another important topic in the organic chemistry that stands out. And as far as this video is uploaded, the next video you can expect is that of the resonance. So it's goodbye for now, and we will meet soon in the next video. Thank you so much for watching. Oh yeah, mathematical functions, yeah, sin x. So let us say d by dx of sin x, cos x, and then we have sin theta perpendicular upon hypotenuse. Okay, so that's a goodbye for now. I was trying to cover up for the time. Thank you so much for video.